crazy.
Oh, man. I won't think they're all like getting
You go to my neighborhood, the only one for you is house. You go to my neighborhood, and the only ones who have this house.
She that loud.
She is loud. I am loud. Like my neighbor knows when she's outside.
Oh my God.
She's like, your mom is outside cleaning. The other day she texted me, she's like, your mom, I think she needs help. She's cleaning what was it, the garden, and she's screaming at your dog. So that's probably just moving your plants or something. What's your breakfast on?
Yeah. I like how you give me your whole packet.
Yeah. It's together, okay?
All stapled together.
Yeah, I'm very responsible. I take everything.
I used to do that in high school, but then I stopped because like I started getting back pain.
I had to buy a locker that I never went to.
I had a locker in high school, but like, it broke my binder, so I never used it again.
Binder?
Yeah, my binder.
Well, I originally thought I wanted to do poetry, but I always pictured like
High school or college.
I want to do special ed
Absolutely.
for middle school.
And then, you know what, it's like it was just great to always fit, and then I would drive.
Because I want to teach algebra.
5 or 9.
You like algebra?
I love it.
That's my favorite part. That's my favorite math. The only one that I actually understand.
My boyfriend jokes that algebra. Because I was so good at it. So you need me to teach.
My mom said that I should be as planned.
Yeah, sure.
And I was like, no.
Mom's like, should teach
In
better.
a
I'm terrible at spelling and writing. I can speak it rather than I can write it. I also took Latin.
It's like, it has like the Spanish grammar, but like 5 times. It's 5 times harder.
This is not how I work together, because it looks like it's like really bad words put together. But it's easy to write.
You know what? I was reading and I was like, I know what it says, but I don't know what tense it is.
It's there, I know what it means. Just leave it there.
My brother and I actually took it together. And like, a lot of words were easy to understand. English, Spanish, and stuff like that.
That's why I love that.
And it was really easy. It was really easy.
I think it's for me, it was easy to learn. Oh, yeah.
Portuguese.
Too cool, but then when you're.
Then English. But English, I had to learn it. I came to live here, and I had to learn it like the first day I came here. So English, I was really good.
Like, I wanted to think that.
It's like so. Oh, English teachers like teach them like,
What are you talking about?
English is weird.
Yeah,
And he's like,
yeah,
yeah,
it is.
because it is.
It really is. And then they say the Spanish language is the hardest one to learn. No, it's not.
It's so easy.
It's easy.
Elementary school is like,
It's just what gets you the tense and verbs and nouns. But you don't need that.
Sometimes I can use like words.
so like, I want to teach.
Yeah, it's easy to figure out how it's spelled as well.
Yeah.
You sound it out. Like, I got to do this. Everything's like
Everything
constant.
is the way you say it, it's just like you said.
Just like you said, but then you're not loose.
But
Yeah, well, and even
Like,
So I'm trying to learn more sign language. It's all these words.
I really don't want to handle. The other one I know, because I'm just like, okay, this is fun.
I like the first two. People are here already versus the second day where you're like, they didn't come to the intro session and so they're all trickling in.
I don't think
Do you want that?
My name is.
Oh, is Iris gonna come?
I like the little.
They were saying they
Oh, it means
they registered.
I mean,
But they're not.
Actually,
Oh, she's not coming?
Desire
I
and
don't know,
Scottish.
I'll check
And
that.
noodles and Chinese.
I like that.
She's the best.
I like that.
She comes in,
It
like, she's one of
literally
those
was-
students
I
when
was
she comes in,
Chinese,
like,
and it
I'm like,
really
okay, I'm
spelled out
sorry,
my
30
name.
minutes is already gone, like, we've been talking this whole time.
Noodles.
I like that.
What's her name? Leon.
Oh, that's cute. Thank you. That's what I'm saying. Mine is like followed on in this little. And then my mom had my sister, she named her the Queen of the Lake. I'm like,
What is that?
Fabiola, Amy's Queen of Lake. And then Paola Little, I was like, whoa, so original of you.
Maybe she just thought your name was pretty.
She thinks it's pretty.
I think I've looked up mine sometimes, and it's like Peaceful Meadow or something like that.
See, why can't we do like something nice like that?
My last name means riverbed.
What?
My
What's
last
that?
name means riverbed.
That's cute. Mine is Maria, so typical.
I guess we'll go ahead and start. I was just telling Jordan, normally the math is on the second day, and then the English language and reading is on the first. So everybody comes to the intro session on the first day, and then no one comes the second day. So it's always people trickling in for the math. So it's kind of nice. Everyone's here as we get started. Now I say that, and someone's going to walk in, but that's okay. So for this session, this is how it's going to kind of look. For the first 45 minutes to an hour, I'm going to kind of introduce the things that you picked up, talk about one of the documents that I created and give you some hints and tips and things like that. And then the rest of the time is going to be practice test. By the end of today, you picked up several practice tests. The one that we're going to do today, and we're going to do all of it, is the one that says mathematics subtest on the top. So you have lots of different ones that say like practice test 1, practice test 2. So the one that says mathematics subtest, this is actually the practice problems from the FTCE website. So I actually tried this new in the February boot camp, and I liked it because I was using those practice tests from the REA book, but I wanted something different. Plus, they've changed the test slightly, so I wanted to see what are they saying. So we're going to focus on this today, and by the end of today, we're going to have all of this done. This morning's session, I'm going to get into what this means, but this morning's session is focusing on half the test. We're actually focusing on competencies 1 and 3, and then this afternoon, we're going to focus on competencies 2 and 4. If you're here all day, you've already picked up everything you're going to need. Same, I see she's writing on the evaluation. Same with the evaluation. You're only going to do one, and you only need to sign in once. So this afternoon, there's no need to sign in again. If the sign-in sheet's out, you don't need to sign in again. If you're not going to be here all day, you've already picked up everything. So if you're not going to be here this afternoon, you've already picked up all of the materials I'm going to give, so you have everything for this afternoon as well. Okay. Just a couple like ground rules, but just sort of expectations that I have and that you can have for yourselves. I'm not holding you hostage here. This is a voluntary thing you're doing. So if you feel the need to, like you've hit your capacity, as we were talking in the break, I find a lot more is in the afternoon, like you had lunch and it's that kind of time of day. And all of a sudden I look out and I see this. If you're at that point where you're like just struggling to stay, then it's time to go. Like I said, I'm not taking attendance. It's not like it's a class where you have to come and have attendance. If you get to a point where you're not taking anything else in, then that's your stopping point. So feel free anytime. Like if you need to get up and stretch, if you need to get up and go to the bathroom, if you just hit your capacity for that moment and you're done, great. You're not going to hurt my feelings if you get up and leave in the middle of this. If you have class that you need to go to, great. It's fine. The only thing I ask is if you fill out the evaluation, if the folder's in the back, if you just put it in there, good to go. Also, I want participation. Like this is not math according to Deanna. Yes, I used to teach math, and that's why I'm doing this. But having taught math and being used to teaching math is different than preparing necessarily for a standardized test that's multiple choice. Sometimes I forget it's a multiple choice test. It's easiest sometimes just to use the answer choices to help you answer. versus let's do the whole problem in this whole crazy way, and then, oh wait, there's answer choices to help us. So remind me of things like that. And in math, yes, there's only one right answer, but there's multiple ways to get there. So if I'm doing something up here, and when I do the practice problems, I'm actually going to ask for your participation. I'm going to say like, okay, what's next? What's next? What should I do next? My philosophy of math is that math is two parts. Math is, yes, some memorization in terms of terms, things like that, but math is also logical. And I want you to start thinking of it that way. And I want you to ask yourself why. Stop memorizing. Do not memorize. The only things I want you to memorize or commit to memory are those kind of vocabulary things. Stop trying to memorize steps to solving a problem. I feel like anybody that's typically good at math throughout like K-12 education, I was good at math, but I think I was good at memorizing. If you ask me now about anything beyond what I taught, so I've taught through 8th grade, so I taught Algebra 1. I've not taught anything above that. So if you ask me about Algebra 2 or pre-calculus or calculus, I'm going to be like, I haven't taken that since high school, more than 20 years ago. I don't remember it because I really just memorized things from the test. So and it wasn't until I got into my math for teachers classes that I started really looking at math in a different way and really understanding the why. So I want you to try to get there. Stop trying to memorize. Don't try to say, I'm going to write down the steps that she's doing and I'm going to memorize what she did. Because as soon as you get on that test and the question is slightly different, you have no idea what to do. So each step, when I'm doing practice problems, I'm going to be like, okay, what's next? What's next? And I want you to think about each step. Why is she doing that? Why is she doing that? Where is that coming from? Start getting yourself used to asking why. Because the more you can internalize it and the more you can understand logically where it's coming from, the more you're going to be able to just do it instead of having to recall things. And a lot of the math in this test is real world math. It's things that you could be doing every day. We all go to grocery stores. We all go, we're consumers. So if you're talking about as something where you're asking about the prices of things, stop trying to memorize what it is. Just think to yourself, okay, if I was at a store and I was doing this. So try to get out of that memorization. So I taught middle school. I taught 6th grade for 4 years, 7th for 1, and then 8th for 2. I used to just go in and be like my 8th graders. I was teaching advanced algebra 1. Advanced kids, but it was the first time in kind of their math career that it was new. Because they'd always, from like 4th or 5th grade on, they'd had the same review. So they were kind of like, whatever, I know it. Now it was new, and I'd have these kids going like, I don't get it. And they just give up. And so having to get them to think about it. But I also would go in sometimes and I'd be like, is this an English class? And they just, they're anybody want to teach middle school? No. Middle school kids are fun because they're like goofy and weird, but you can like be sarcastic and strange with them. Sometimes they get it, sometimes they don't. But I'd be like, is this an English class? And they just look at me. They're like, no, what are you talking about? I'm like, it's a math class. Not an English. So why are you just copying what I'm writing? I'm not teaching you how to write. And that's what they were doing. They were just mindlessly writing each step that I would do. And that was it. They weren't thinking about it. So I want you to do that. I want you to think about what you're doing and what you're writing. Okay? Let me think. A couple things I want to talk about. Oh, first, competencies. We're talking about that. I'm going to pull up this. So again, we talked about this during the opening session on the website. But when I keep talking about competencies, I want to make sure you understand what I mean. So again, test is 4 subtests. So we're going to be looking at the math under resources, competencies and skills blueprints. Doesn't matter which one you choose. It's all going to go to the same thing. I'm going to scroll to the math. So this is what the math is made up of. 17% of the math is made up of competency 1, which is number, sense, concepts, and operations. 21% geometry and measurement. 29% is algebra, and 33% probability statistics and data interpretation. So when I keep talking about competencies, this morning we're focusing on 1 and 3, this afternoon 2 and 4. And you kind of see the breakdown. The majority of the test is 3 and 4. I would argue that one kind of goes throughout because that's just computation. But what do you need to get to pass this one? Do you remember? 72%. Let's do a little bit of math. We are, in fact, in a math class. So there's 40 questions, so 72% of 40. How do I solve a problem like this? So change percent to a decimal and multiply. So somebody do that. What do I get? 0.72 times 40. And I want everybody, get your calculators out, because while we're doing this, and your phone has a calculator, while we're doing this, when I'm going through the problems, like I said, I'm going to be asking for your participation, and I don't want the same 1 or 2 people to participate. I want to hear from everybody. So if you notice you're the person that's always answering, hold back a second and let other people take a second. So what did you get?
28.8.
28.8?
Yeah.
So since the GKT won't let you get 0.8, right? Let's round up. So we need to get 29 correct. And I always say this for those of you that are negative realists in the world. That means how many did everybody else get 28.8?
Yes.
Okay. What's 40 minus 29? Well, if it's we round it up. So that means you can miss 11 and still pass. Now I talked about this morning. Remember, it's pass, fail. If you pass it, all we know is you pass. It just says pass. We don't know if you got 100 or a 72. You passed. So I want you to keep in the back of your mind, I can miss 11. I don't have to be perfect. I also don't have to let it freak me out if I don't understand something. Okay, so keeping that in the back of your head, I always say, go on to this site and just sort of click around and use, this is a good kind of, outline, but there's also some other good resources on here. Like for instance, they have the tutorial. That is the actual tutorial you get in the testing center to tell you how to use the computer and how to kind of practice all that. So just click on everything, see what all they have. All right, let's look at a couple different items that you have in front of you. Actually, first, let me see. How many of you have never taken the math GKT? Okay. If you have taken it and you have to retake it and you want to offer any sort of suggestions or advice while we're going, please feel free. The majority have not taken GKT, so we can learn from each other. So if you're one of those people who has taken it and you feel comfortable, you can say, oh yeah, I had a question like that. Oh yeah, I remember something like that. Things like that. But most of you have not taken it, so it's a little different. Sometimes I have more people that have. Okay. First thing I want to show you, well, let's think. If you're in a middle school classroom, now, don't freak yourself out because you're going back to, because we're going to get in a time machine, we're going to go back to middle school. But when we're back in middle school, we're going to be our current selves. You're not going to be awkward. You're not going to be like shy or not shy or whatever you are, we're in middle school. But you're yourself in middle school. Think back to a middle school classroom when you're learning math. There's usually kind of a process. You have a textbook, right? I always loved that first day of school. Like, you got to take that textbook home and they wanted you to cover it and all that kind of stuff. My mom would never buy me those covers. Like, she's like, there's brown paper bags. Go use that. Oh, but mom, so-and-so has the shiny one. And she's like, I don't care. It's going to get ripped. Do that. So you covered it. You have that textbook. So when you're learning it, you've got a textbook. And textbooks typically follow the same pattern. It's like, introduces the concepts. There's some practice. And then what happens at the end? In math, probably every night you had what? Homework. So that's what I want you to do. You're back in middle school. I want you to take a look at this document that you have. It says GKT Mathematics Preparation GKT Booth Camp. What this document is your textbook. I want you to write textbook on the top of it. I want you to think of this as the textbook. What I did, so I was not certified in Florida, like my original, I went to school in Ohio, so I actually certified in Ohio, but then I moved to New Mexico, moved my certification over. So I taught in New Mexico, I didn't teach here in Florida. So I never took the general knowledge test. We had the praxis is what we did in Ohio. So when I moved here, they found out, oh, you used to be a math teacher. I was an advisor here in the College of Ed. These people need some help. So I started tutoring people. And when I was tutoring them, I started realizing, first of all, this math is, I would say 7th grade. But before you panic and say to yourself, oh my gosh, it's 7th grade, like either I was really bad in 7th grade at math or oh my gosh, I can't pass it because it's 7th grade math, what's wrong with me? Don't think of any of those things. I would say it's general, but it's very, 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 very broad. It's like an entire year's curriculum of 7th grade. So when I started tutoring, I was like, how do I tutor someone on what I taught over the span of an entire year in like an hour? And I'd never taken the test, so I didn't know anything really about it, just based on what the books. If you have the Cliff Notes book, I would not use that one. Cliff Notes book, I feel like is more advanced than you need to get, which panics you. You might just use the resources I'm giving you. Forget the books. So what I did is Lindsay and I said to our director, we want to take the test because she was tutoring people on English language, and neither one of us had taken it. You're like, you opted to take the test on your own? Yes. But I didn't want to pay for it. So we got the dean to pay for it. So they paid for me to go take the test. And I originally was like, I only want to do the math. I'm only going to take the math. And Lindsay's like, if I'm going to take the math, you're going to take the other 3. I'm like, fine. So then I'm like writing an essay and all this stuff. I'm like I said, the reading was hard. So be prepared. So anyway, I took the test. And when I was done, I just sort of brain dumped. And that's where this document came from. I went through, you know how I just showed you competencies and skills? I went through every competency and skill underneath, and I came up with tips based on that and like examples. So I went through the entire test, every competency and skill, you just sort of leaf through. You'll see examples, you'll see tips, things like that. So what I want to do first this morning is there's some things I want to point out in here. Remember I said 2 parts, vocabulary of math and logic. So the vocabulary and some of the sort of things to commit to memory, we're going to go through those quickly and I'm going to point them out. But I'm also going to talk about some of the tips. First page, overall tips for the test in general. A lot of you, the majority of you, have never taken this test. So I want to kind of introduce you to what to expect. I always joke about this, but it feels like this. So when you go to take the test at the testing center, it feels like you're checking into prison. It's seriously, because they check your ID all these different times. They do all these fingerprints. They take this picture from a really awful angle. They make you check your pockets. Like it's really kind of nerve-wracking because you're like, my gosh, I'm not a criminal and I am myself. I'm taking the test for myself, but the security is very high in terms of making sure people aren't cheating, I guess. So preparing yourself for that. So you go in, you do all these things, you have to put all your stuff in a locker, you go into the room. You get a reference sheet. I believe now they're giving them on paper automatically, but if they don't, I recommend that you ask for one. If you look at one of your practice tests you have in front of you, like one of the ones that says practice test 1 or practice test 2, the last page of the practice test, so not that one, and any of the other ones. No, it's okay. So any of the ones that say like REA, that last page, front and back, is the reference sheet. You might want to just have that available for today while you can just look at it, but that's the reference sheet. So it's good to familiarize yourself with what resources they're giving you. You'll notice they're giving you conversions. You don't have to memorize like how many ounces are in a cup, all that kind of stuff. It's there. You don't have to memorize different formulas. So that's the reference sheet. They'll give you a reference sheet. It's on any of the practice tests. They say practice test 1, whatever, that last page. They also have a calculator. I would recommend that you ask for a handheld calculator. There is a calculator on the screen that pops up and you can open it and close it. But I would ask for a regular one to hold, because the one on the screen is annoying because you can't use the number pad. You have to actually click like with the mouse. So asking for a calculator, you can ask for that. You also get a booklet that's like a laminated kind of booklet, and a wet erase marker. So that's your scratch paper. It's a big booklet, so it's not like a piece of like a whiteboard. You've got a whole booklet of scratch paper. Those are the kind of things they give you. What I suggest, there is a tutorial at the beginning of the session that goes through kind of, like I said, how to go from question to question, how to click the answers, how to access the different things and move the panes around. Even if you've taken the test, I suggest you take a minute, go through the tutorial. Because you've already gone through this whole process of getting in there, you might be nervous. The tutorial is not timed, so it's a time for you to kind of just sort of take a breath and kind of relax a little bit and learn about the test before you get started. Couple of other things I noticed, so the calculator, it's just a basic 4-function calculator. So it's not like your advanced calculators that have different, abilities on them. This is not. This is one of those ones where, you press like, say you're doing like 5 times 3, which you shouldn't do that on a calculator, but what if you are? It's one of those where once you push the 5 times and you put the 3, the 5 goes away. So the key, make sure you can't see a string of numbers that you've put in. So make sure you're being very careful about how you input things. My calculator had a fraction button, which I didn't really use, but it had a square root button, which is helpful. So you don't have to memorize square roots. It also, this is very helpful. It had a plus minus button. So you don't have to worry about remembering those integer rules, like how do I add and subtract positive and negative numbers? If you can't do it, you got a calculator to do it. Let me think if there's anything else. Oh, the booklet, one thing I suggest, so if you take all the tests at once, the math is last. So if you're going in there and you've got some things you're trying to remember, I suggest before you get started on the essay, which is first, just jot down a couple things onto that laminated paper. If there's a couple, like, if there's a vocabulary word you're trying to remember, if there's a formula, whatever it is, get it out of your brain and onto that paper so that when you get to that math session, which is last, it's still there. You're not having to try to recall it. Another thing that the computer system allows you to do is mark questions. So if you don't know something, it lets you mark it. And then you get to the end of the test, it lets you go back to the ones you marked. So my suggestion for you, how many can you miss and still pass? 11. You can miss 11 and still pass. My suggestion for you is if you read that question and within 30 seconds of reading that question, you're not sure what to do, mark it and move on to the next one. Because you have an hour and 40 minutes for 40 questions, which is a little more than 2 minutes a question. But some of these questions might take you longer than that. So get the ones you know fast. And then when you get to the end and you go back, you have more time on the ones you need more time on. Instead of running to, how many of you get stressed out about like a timed test? Me too. I would always like keep looking at the timer, looking at the test, looking at the timer, looking at the test. Like, oh my gosh, I'm gonna run out of time. I'm gonna run out of time. It always happens. If you get onto a question, number 1, you got it. Number 2, you got it. You get into number 3, all of a sudden you're like, I don't know what I'm doing, and you just blank. And now you've used like 5, 6, 7 minutes, and you're like, well, now I'm gonna fail because I've wasted all this time. So don't do that. Get the ones you know first, and then when you go back, you can hit the ones you need more time on. And if you want, while you're going through, do some sort of tally so you know how many you've marked, just as like a mental thing, because you can miss 11. So what if you get to the end and you're like, I only marked 10? You feel pretty confident. Like, okay, good, I think I'm pretty confident. So mark and move on. That's my biggest thing. And then, because the test actually follows the competencies in order, so I've heard multiple people tell me that last section, probability, statistics, data interpretation, all those graphs and stuff, it's not very hard. A lot of people say, yeah, that part's not difficult for me, but those questions can take a while because it's a lot of reading and or looking at graphs. And I've had multiple people say, by the time I got to the end, I was running out of time. And they were questions I knew how to answer, but I didn't have time to answer them. So if you've marked and moved on, you've given yourself time to get those, and now you're giving yourself even more time on other things. So kind of play the game of the test in terms of time. Let me think if there's anything else. Anybody who's taken it want to offer any suggestions? No? You don't have to. All right. In competency 1, there's a couple things I want to point out in terms of sort of things to highlight. On the first page, that was cute.
That was the cutest sneeze I've ever
Was that a sneeze? One of my college roommates would be like that. She'd be like, they'd be like, meanwhile, I'm like, and we always make jokes. My grandfather would be like, I was like, Granddaddy's gonna blow the house down with his sneezes. My mom's the same way. I'm like, Mom. But anyway, sorry, that's cute. Okay, so now I'm gonna go through a couple things that I want to kind of point out to you, just as tips / things to kind of commit to memory. First is on this first page. How many of you, as soon as you see a fraction, it freaks you out? Like that question went from a 5 to a 12 in terms of difficulty, because fractions are just scary. But what do we know we can do with fractions? What's it say? Change a fraction to a decimal. You have a calculator. How do you change a fraction to a decimal?
You push the button.
Well, that button's a 1 over something, so it's not really very helpful.
I'll add like the switch fraction to decimal.
Oh, well, you can't do that on those. You've got a 4-function calculator. Nothing, basic. Divide the numerator by the denominator. So take the top number, put it in, divide bottom. Now you've got a decimal. And you've got a calculator so you can compute things. And it's a multiple choice test, so at the end, if you need to and the answers are in fractions, change those to decimals and estimate. So don't let the fraction part throw you off. Change it to a decimal. Just a couple other ones in competency 1. The only other one I believe is on page 4. PEMDAS. Everybody remembers PEMDAS. What is it? PEMDAS. Well, no, what's the?
Please excuse my dear Aunt Sally.
Please excuse my dear Aunt Sally. People have so what you were saying, parentheses, exponents, most people have no problem remembering PEMDAS. You just like drill that into your head. The thing they don't remember, I would always have my students write it like that and write those little arrows over it. The key to order of operation is once you get done, so you do your parentheses, and within the parentheses, you have to do order of operation. Get your exponents. Now you're down to only multiplication, division, addition, subtraction. The multiplication and division is first from left to right. People memorize PEMDAS and they automatically say, all multiplication must be done before all division. No, that is not true. It's left to right. So if division comes first, you do it first, and then you multiply. So I always put those little arrows like that because it helps to kind of remind me, okay. And the same with addition and subtraction. Once you get to addition and subtraction, you can just go left to right in your problem. So remembering order of operations and remembering those two things. Okay. I think that's all for competency 1. Let's go to page, let's see, 20. We're skipping to competency 3. On page 20, so the reference sheet has a lot of formulas, like it has the midpoint formula, it has the distance formula, it has the slope formula. One thing I think that it should have that it doesn't is this one. So I want to make sure you're kind of remembering the slope-intercept form. I'm seeing some faces like, oh no, you're taking me back to algebra 1. It's okay. Slope-intercept form, y equals mx plus b. Remember, this equation, has to be in that format for it to work. So the y has to be by itself, no coefficient. The m is whatever number's in front of the x. So like say it was a 3. The m is the slope. And then the number at the end is the y-intercept. So where it crosses, which one's the y-axis? Vertical. So where it crosses the vertical axis, So remember when you were graphing lines at the first, and you would say, plot the point, like if it was -3, go to -3, put a dot, and then use your slope to find at least 2 more points and then connect them. So remembering slope, y equals mx plus b. Another thing to remember is, yes, you've got the slope formula on your reference sheet, but I feel like sometimes the slope formula takes a little longer than just thinking of slope as rise over run. How much should I go up or down, which tells you if it's positive or negative, and how much should I go to the side? So you're going to climb, and then you're going to run. So rise over run. Okay? Look at page 21. This one is a big one. This one is one, if you remember this rule, you're going to easily get 1 or 2 questions within those 30 seconds. A function. So if you've taken the test before, it talks about what relation is a function. A function is a relation. So relation is just basically meaning ordered pairs. So relation between the x's and the y's. A function is a relation where each x value has only one y value. So each x only goes to one y. If you're talking about, so no, in other words, I left out the word no, which is a very important word in this. Bless you.
Thank you.
No x values are repeated. So if you're looking at, like, for instance, number 60 down here, and you're looking at a bunch of ordered pairs, oh, this is another thing to pay attention to. Not only is the GKT a math test for math, it's also a reading test. Make sure you're paying attention to if it says, like, which one is not true, which one is not the solution. They always try to catch you with that. But in number 60, for instance, which of the following does not represent a function? This one, because the x values are there more than once. It's okay if the y values are there double, as long as each x only goes to one y. In this case, the 3 goes to 12 and 15. So no x's are repeated. If there is a graph, graphs are functions if they pass what's called the vertical line test. So if you have a graph, so say you have a line, as long as you drew vertical lines through every point in that graph and it only crossed the graph in one place, then it's a function. So like, for instance, this line is a function because every line crosses only one point. This one, this parabola, is also a function. However, this parabola is not, because the line, the vertical line, would cross more than one point. Oh, I forgot one key thing, your homework. You're all grown, just kidding. So remember how I said I did that textbook, which is what we're looking at here? So I did the textbook, and then I went through every competency, and I created homework packets. You don't have those. This is what I'm emailing you. So I'm going to email you, probably today, if not tomorrow, packets. You're going to get 4 packets. They're going to be like this. Their first page is going to say, like, this one says, drill for competency 3. So this is competency 3. I went through, and I found, like, worksheets, and I did just like, remember when you were a kid, you went home and you did those worksheets, and sometimes they would have, like, one of them worked out for you, and you had to do the rest? That's what I did. I created homework packets for each competency, so you can practice. So here, we're talking about which ones are not functions. Very easy, and the answer keys are there. So you're going to be getting this via email. I used to print them all out, but then it was like this much paper for every single person. So now you're going to get these for homework. All right, so back to here. One thing I came up with in terms of remembering, because if you misremember this, if you memorize it as no y's are repeated, then you get it wrong, right? So the way I remembered no x's, I just came up with this one day. So brilliant. I said, it's like relationship goals. No x's are repeated. Once they're an x for a reason. Don't go back. That'll help you remember this. No x's repeated. Some people might be like, well, we broke up and then we got back together and we got married and we've been married for 45 years. But okay, whatever. Not everybody. But no x is repeated. So think to yourself, relations are functions. A relationship is no x is repeated. Okay? All right. Page 22, next page. On 22, it's talking about lines that are parallel, lines that are perpendicular. When I taught 6th grade and we got into our like geometry unit, I always did like geometry aerobics with them. You gotta get like kids moving, like 6th graders, they need to move. They need to do something other than throw pencils at each other. I used to tell my 6th graders, I'd be like, did I ever tell you guys why I didn't teach kindergarten? And they'd just be like, no. I'd be like, Miss Ricky, so-and-so throwing the pencil at me. And they're like, I'm like, stop complaining and stop throwing pencils. Stop messing with each other. That's what they do. It's always I have to sharpen my pencil. You know, I'm talking to everybody on the way to the pencil sharpener. I'm like, stop. Okay, you're good to go. Anyway, so in this, I would have them go, okay, show me parallel lines with your arms. Show me parallel lines. Lines are parallel. Think of the lines on the road. They're parallel. They don't cross. Football. Show me football. Show me perpendicular lines. They cross at what angle? A 90-degree angle, a right angle. So it makes sense that if two lines are parallel, they have the same slope, right? So they want to know two lines are parallel, like on number 61, you're given the equation, y equals 3x plus 2. Identify the line that is parallel. You first need to identify the slope, so the m, slope is 3. And then you identify which one also has a slope of 3, and that one is parallel. Perpendicular lines, the slope is the opposite reciprocal. Opposite meaning one's positive, one's negative. Reciprocal meaning flip. So reciprocal of 2 is 1/2. Reciprocal of 2/3 is 3/2. Reciprocal of 1/2 is 2. Remember? So you also find the slope. So in this number 62, the slope is 5. The opposite reciprocal would be negative, because one's positive, one's negative, 1/5. So that's just sort of vocabulary to commit to memory is slopes that are parallel have lines that are parallel have the same slope. Lines that are perpendicular have opposite reciprocal. And that's all on competency 1 and 3 to point out. 2 and 4 have a little bit more in terms of things to point out, but we'll do that this afternoon. Okay, before we move on to doing practice problems, I want you to, I use this a lot and it's getting kind of messed up. Feel free to take a picture or whatever. This is just a word problem strategy that I suggest, because a lot of the GKT, like I said, are word problems. So yes, you know how to do math, but now you have to read and figure out what to do in the problem. So this is something I used when I taught. So first thing, makes sense, read the problem. Remember, what did I say? If you don't know how to do it within 30 seconds of reading it, what should you do? Mark it and move on. Read the problem. Now you're on a computer. So you're taking the test on a computer. You got that laminated paper in front of you, that's your scratch paper. Instead of continually going up, down, like looking at the computer, looking at the paper, I suggest write down really quick like the important things. If the question is talking about 15 students did blah, 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 just write down real quick 15 students. Whatever you want, but take it off the screen and onto your scratch paper. So you're not continually going back and forth. Read the question, what is the problem asking you to solve? So go to the end, what's it asking? Draw some sort of picture or diagram. How many of you are visual learners? Kinesthetic would also fit with this as well, because you're actually taking the time to draw or move. So draw it, get it in the picture. So some of you might picture it in your head, but put it on that piece of paper. If they're talking about, the classic problems of the height of the tree and the shadow and the height of the person and the shadow and all that kind of stuff, draw 2 triangles, because that's what they're talking about. Solve your problem. And number 6 is key. That's why I put a star next to it. At the end, go back and reread the question. Did you answer what the question is asking? Key with multiple choice tests, they always get you. You might have a problem that has like 3 or 4 parts. You better believe it. In that answer choice, they're going to have the answer to that first part, and you're not done. So don't get too excited. You're like, oh yeah, the answer's there, I'm done. And then you realize you only found the perimeter of, or you only found the width of something, but they wanted to know the area or whatever. So make sure you're rereading and answering what the question's asking. Make sure you're taking notes, and I'll say this again this afternoon when we get into measurement, of any sort of units. So if the question is in inches, but the answers are in feet, make sure you're taking note that, oh, I need to change my units. If they're asking about, volume versus area, make sure you're paying attention to those little things that you could easily miss. And then I just wrote, you can do this. Like, you can do this. And I have a quote from Helen Keller. Optimism is the faith that leads to achievement. Nothing can be done without hope and confidence. So again, not a magic little wand, like just because I believed, it means I can't. But going in with more confidence, so hopefully going through something like this boot camp and doing the practice problems that you get through your email will give you more confidence when you go in. So you're ready to go this, because you can do this. You haven't done it yet, but that doesn't mean you're not going to do it. Okay. Any last comments before we do the practice? All right, so we are going to do, like I said, we're going to do competency 1 and 3. So we're going to skip over 2 and 4 until this afternoon. So if you're here this afternoon, we're going to be doing those then. Can everybody see this okay? Is it okay? But it's okay. No, it needs a little more. What does it need?
It needs to be darker.
Do you think does that help at all, like moving the light away from it? I know. I can turn off the light. I don't know how. Lamp. That made it worse? Okay. Well, let's try. Do you guys okay with me turning off the light?
Yeah.
Okay, let's try it. So somebody turn off one of the lights back there. Well, now I've just turned off. Okay, here we go. Is that better? No, the front one would be better. Is that better?
Yeah, it's coming out. Can you enlarge it just a little?
Yeah. Is that better?
There you go.
All righty, cool. Well, at least you have it in front of you too. So, okay. Number 1. Which of the following symbols do we place in the box to form a true statement? Now, let's talk about these symbols first. So you've got greater than, less than, right? So how did you learn these? When you learned this, how did you learn it?
The alligator.
The alligator eats the bigger number. So it was like super simple. They put 2 numbers in the little box, like exactly like this, not necessarily negative fractions, but they put 2 numbers in, and then you just put the alligator eating the bigger number. And then they ask you to identify what they actually are. And people are like, wait. So I'm going to give you a little tip just in case you need to know. So if you make an L with your hand, that's an L, right?
I hope so.
Yeah, L. And just turn it, that's less than. L, less than. So that's the less than symbol, less than. Okay? And then this is obviously greater than. And what is it if there's a line underneath? Or equal to. So it's greater, or it's less than or equal to, greater than or equal to. Okay. Let's go to this actual problem. One thing you might do is draw a number line. Sometimes that's helpful to actually put like a number line down. Now we're talking about negative fractions, right? So if we're talking about negative fractions, they're going to be, and then neither one of them is an improper fraction. So these 2 fractions are somewhere in between 0 and -1. So I might, and this is just if you need to do this, I might do like this just to help myself. Just to remind myself, because remember on the negative, it's like the opposite. Okay, so what would be my suggestion? What would you guys suggest I do? Anybody have a suggestion? What would you do? Let's change it to decimals. Okay, so -1/3 is what? -0.333 repeating. Okay, and what's -2/5? Negative. Okay, there we go. 0.4. And let's just make it 0.40. Okay, 0.4. All right, so what am I putting in there? Greater than, less than, obviously they're not equal to. So it's not A, it's not D. So negative 1/3 is greater than negative 0.4. So you could do a couple different things. You could look at, remember on the negative side, it's the opposite of what it would be positive. So you could look at it as like 33 and 40. Well, 40 is greater than 33, but when you're on the negative side, it's the opposite. So negative 33 is bigger than negative 40. You could think of it on the number line. 1/3 would be about here. 2/5 would be closer to 1/2. So anybody else think of it a different way? Or is that kind of how you would think of it too?
I was thinking of like converting like the 1/3 to like over 15 instead of like trying to convert it to decimals.
So changing them into the actual same denominator? Okay, what did you get?
I didn't do it.
Oh. 5/15, right? And then 6/15.
Yeah.
So 5/15 is greater than 6/15 when you're talking about negative. Okay, good. Anybody else?
If you cross multiply.
When you cross multiply them, that's what you're talking about, like a proportion. Proportions are equal. I never taught the cross multiplication method of deciding whether it's positive or what they're greater than or equal to, or greater than or less than. Do you remember the rules for that? Do you remember doing it?
Mm-hmm.
I don't remember. I never taught it, so I don't want to say the wrong thing. But if you did cross multiply, I mean, you could do like 1 times 5 is 5, and 3 times 2 is 6. But I don't know what that even will tell us.
Put the negative in front.
So negative 5 is greater than negative 6. We'll have to see if that actually works for all of them. But yeah, if that's a method, because I never taught that method, so I maybe vaguely remember learning it when I was a kid, but I think I just sort of forgot all of that when I started teaching it. But yeah, that's good. We'll have to test that for another one, see if it works. So pretty easy problem, right? Obviously very easy putting the alligator in, but as soon as I throw in negative fractions, you're like, what? But you know how to change it to decimals, so you can do it. Okay, number 2. I gotta make sure I can fit everything on here. Oh, gosh. Trying to get it big enough so you can see it, but also enough to show the whole thing. Okay. All right. The regular price of a computer is $1,200. And the regular price of a printer is $300. An electronics store has a promotion that offers a 40% discount on the printer when the computer is purchased at the regular price. What is the total cost of the computer and the printer at the promotional price? So any suggestions? What should I do?
So, I know like when you say 40% discount is off.
Mhm.
So I don't know if it's because I'm a server, so I'm like always doing that kind of stuff. Like for like tip wise.
Mhm.
But I always do 60% instead. So I don't know if that would confuse people. but
So
that's
if-
what I do.
Good. And that is something I do when I go into stores. So if it's 40% off, right? That means what percentage of it are you actually paying? You're paying 60%. So she's saying 40% off. So I want to know, okay, what is 60% of 300? I do it all the time when I'm at, I don't shop that often. So if I do go shopping, so I like to, my sister and my mom and I always go the day after Christmas to the outlet malls. My mom lives in Orlando. We go like 7 a.m. the day after Christmas because everything's like super cheap. But I just have my phone out and you go up and it's like, this is like 60% off. So I just say 40% of the price and that's how I know how much I'm paying. So that's exactly what she did. So she said, okay, well, I'm actually going to pay 60% of the 300, which is the same thing as going 300 minus 40% of 300. So I could find the 40% and subtract it. But let's do, what is 60% of 300? 180? So the printer is 180 and the computer is 1200. So what do you get? 1380. 1380. All right, cool. Relatively easy. Again, very real world. I'm glad she said that because it is. This is not one of those, I need to memorize the steps. If it's this, I do this. But just think of it logically. If I'm at a store and I'm going to pay this percentage of it, how do I calculate that? Relatively easy? Are we feeling pretty good about this? Are we feeling like if I have 2 questions like this, I know I'm going to get them right? Maybe, hopefully, yes. Okay, good. Okay, let's look at number 3. Which of the following symbols, so again, one of these should be placed in the box to form a true statement. So we're talking about positive numbers now. Are they equal to each other? No. So we know we can cancel off A and D. It's either greater than or less than. What should I do? Anybody? What did you guys learn?
What if we round up?
Round up. When you say round up, what are you rounding?
Well, it becomes 3.31. You didn't want to do that, and then it just 3.3. 3.3 is less than
3.3. Yeah. Okay. So she's saying she estimated them. What else have we learned, or can we do? Could do a number line. Now, if you want to find out where 0.4 is and 0.309 is, what's another thing? Do you guys remember what I'm doing right here?
Oh.
If you make them the same length, now you're talking about 400 and 309. So same thing that she did. She said she estimated. Okay, so it'd be like 3.09, so 3.31, which is still 3.3. So what is it? Greater than or less than? Greater than. So lots of different ways. You could look at a number line. You could estimate, make it. So notice by me putting the 2 zeros, I made them the same length. So now you're comparing the same. You don't have to worry about the 3. Now you're talking about 400 and 309. Okay, relatively easy. You guys are 3 for 3 now. You got 3 problems right. You're good to go. Sure, I might have to pull up that answer. Do you still have the one? Remember last time I messed up on that problem? You emailed it to me. I don't know if you. Remember, I was like, Jordan, can you Google this problem?
Oh, yeah. Okay.
I'm gonna need to see that one again. Okay. Students in a mathematics class are allowed to drop their lowest quiz grade. This is normal. You guys tend to do this in your classes here, right? Yeah. A lot of times you've had classes where you have, 3 tests and a final, and your final takes the place of the lowest test, right? They're trying to normalize. What they're doing, and we're going to talk about this afternoon, they're actually taking out the outlier. But okay, students in a math class are allowed to drop their lowest quiz grade. If a student earns the following grades, which grade will be dropped? All right. Now, 6/8, 2/3, 73%, or 6/10. What should I do? What do you guys want to do? You convert them all to percentages. So how do you do that?
Divide the numerator.
Divide the numerator by the denominator, and then you get a decimal, and then you move the decimal place 2 places, right? So what's 6/8? 0.75, which is 75%. Okay. What's 2/3? 67. And then we have 73. And then we have 60. So which one's the lowest? 6/10. Relatively easy, right? Just reminding yourself of the kind of operations rules and things like that you probably haven't done in a while. Okay? Any questions? All right, number 5. An electronics store has a current inventory of 50 stereo systems. The lowest priced stereo system is in the store sells for $800, and the highest priced sells for $3,000. Which of the following is the maximum amount of $3,000 systems on hand if the current inventory totals $111,000? What should we do?
Divide 111,000 by 3,000 or 3. Yeah.
So you divide it by 3,000? Why did you do that?
Because it asks for like how many 3,000s go into like
111,000,
What'd you get?
37.
So there's that. How many people would put D? There's one other key thing we need to make sure we do. They have to add up to 50 as well. So the, whatever you have for A, which is a 3,000 level one, we'll say, or 800, plus B has to be 50. And so let's keep going. So let's test that out. So if you did 37 at 3,000, what's that? What do you get? That's equals exactly 111? So does that give you enough left for 13 of the other ones? Nope. So we can guess and check like we're doing here. So let's try, do you think 35 might be too high?
Yeah.
Let's try 32. So 32 times 3,000 is what? 9,600? So then so that means how many of the other ones would have to be there? If there were 32 at 3,000, in order to add up to 50, there'd have to be 18, right? So what's 18 times 800?
14,400.
14,000? 400? Does that add up to 111? No. Can't. Oh yeah. it
No,
could.
you're missing a zero.
This does, right?
You're missing a
Yeah, you're missing a zero at 96.
It's 96,000.
Oh, 96,000?
Mhm.
Okay. Does that add up to 111? 96,000 plus 1440? I don't have my calculator.
No.
Nope. So it's not 32. So we want to try next. 30 or 35? 30, okay. So then 30 times 3,000, which is 90,000. And then what's 111,000 minus 90,000? 20, right? 21,000. And that means you need 20 of those. What's that divided by 20?
1,050.
How much?
1,050.
1,050. So it's not 30. So it must be 35.
Oh, wow.
Okay. Now that's one long way to do it. There is another way. Would anyone do it? What's another way people might do it?
I would do it where I put A plus B equals 50 and then 3,000 A plus 800 B equals 11.
She's doing, yep. So A plus B equals 50. This is a system of equations. So 800A plus 3,000B has to equal 111,000. I used to love teaching this. So in a system of equation, there are multiple ways to solve it. One way is substitution. So if I say A equals 50 minus B, do you guys agree that that's the same thing? I just moved the B over. And I take this A and substitute in for this A. Now I have 800 times 50 minus B plus 3,000 B equals 111,000. Are we with me here? Is anybody not sure what I did, where I got things? Okay. What do I need to do with this 800? Distribute it. So 800 times 50 is what? 40,000 minus 800 times B plus 3,000 B equals 111,000. Keep on going, right? Now we just have an algebra problem. In algebra, what's the key? If I say I want to solve this equation, what's the key? What do we need to do? The goal is always to isolate the variable, right? We need to get that b by itself. And what equations are to solve them, so you know how you have order of operations? When you're solving equations, the reason we add or subtract first is we're undoing the order of operations. The last thing we did in order of operations was add and subtract. The first thing we have to undo is adding and subtracting. Does anybody want to combine terms first? Yep, okay, let's do it. So we have 40,000. What's 3,000 minus 800? Oops, sorry. 3,000 minus 800. 2,200? Right? Like, wait, that's too big, we got 100. Okay, now we're going to subtract 40,000. That's what we're doing now. Yeah, you could tell her. Yeah. System of equations. What's 111,000 minus 40,000? Take off these zeros. 71,000? And then we just divide by 2,200. So what do you get?
32.27.
Anybody else get that?
Am I crazy?
32?
Yeah.
And what's the answer? 35? Did we do this wrong? What is the actual answer? The answer key is at the end, by the way. Is the answer 32? Oh, sorry. We messed up when we did it earlier for some reason. Okay, so 32 is right. Sorry. So you got 32.2?
Yeah.
And you can't round up, so you're going to round down. So B, you have to have 32. Now, that's a really long way to do it, right? How many people would do it this way? How many people would rather guess and check? How many people would just sort of estimate and move on? And that's okay too. If you get to this kind of a problem and you're not quite sure exactly what to do, try the largest and the smallest. If they're way too big or way too small, then choose one of the ones in the middle. But clearly, we messed up something when we did the 32. I just don't have my calculator in front of me, so I don't doing it for me. But, okay. Any questions? Yeah, this one, or do you want the other part? Oh, yeah, sure. Does anybody want this? So I guess the 32, we did it wrong, right? So what did we do wrong? Was this, are these,
When I did it, it came out to the answer. I did it again. So
oh, we just estimated too much. Like, is that right? Like it was slightly too high, so that's why we did it. Okay, so it makes sense. It's the closest to it. All right, anybody still need this? Okay. Last one on competency 1, and then we'll move to competency 3, which is algebra, which was what we were just doing. Okay, order of operations. So what's always the key? What's the PEMDAS? First thing I do is parentheses. Now, when I taught order of operations, I at first made my students write everything out and underline the step that they're doing and all that kind of stuff. I do find it's helpful because you can get stuck. But again, this is a timed test, so take as much time as you personally need to. I think we can do all 3 parentheses at the same step. We don't need to do one at a time. So 15 minus 3 is 12 divided by 2 plus 1 is 3 times 8 minus 6 is 2. So this is a perfect example of a super simple problem, but if you did not remember the key of what? When you get to multiplication and division, you need to make sure you do what? Left to right. So that division comes first. Because if you did 3 times 2 is 6, 12 divided by 6 is 2, but we're not going to get 2. Are we? No. Okay, 8, right? 12 divided by 3 is 4, times 2 is 8. Notice how 2 is there as an answer choice? Because if you did not remember the rule of first from left to right, you would get the wrong answer, D. All right. You want? I'm not going to get to that one for a little bit, but when I do, I'm going to not be so upset like last time. Okay, let's skip through competency 2, and we're going to do that this afternoon. Where does competency 3 start? Page 7? Okay. Number 18. So now we're moving into algebra, coordinate planes, that kind of stuff. And this is, I think, 30% of the test. So competency 3, a third of the test. Okay, which of the following is a solution of the inequality? So we've got inequality signs. You solve inequalities just like solving an equation. Until the end. At the very end, the key with inequalities is when you get to the last step. You know, the last step when you're solving equations, you move the add or subtract things, move them around, and usually divide or multiply at the end. If you multiply or divide by a negative number at the end, you have to do what to the sign? Just say, flip it. So if it's a greater than, it becomes a less than. That's the only thing to remember that's different about an inequality. So we've got -3 is less than 2x plus 1, which is less than 5. And you can solve this at the same time. Some people would prefer to write it like this. -3 is less than 2x plus 1, and 2x plus 1 is less than 5. So splitting it up into 2 problems and solving them separately. Are we okay if I solve them at the same time? Okay. So when you're solving them at the same time, you just, when you add or subtract, you do it to both sides of the inequality. So I'm going to subtract 1 from all parts first, because remember that gets rid of the 1. So then we have -3 minus 1 is -4. And remember, you have plus minus on your calculator if you need to. There's no shame in using it. And on those 4 function calculators, the way you do the plus minus, if you don't remember how to do it, so if you're like, you put the 3 in, you hit the plus minus button, then it shows up as -3. So you can use it if you need it. So we have -4 is less than 2x, which is less than 4. Okay, we've got a positive number here, so we're going to just divide by a 2 on all parts. So we have -2 is less than x, which is less than 2. So what does that tell us? X falls where?
Right down the middle.
Between, it doesn't have to be in the very middle, but x is somewhere between -2 and 2, right? Do you guys agree that that's what that means? X has to be larger than -2. X is greater, and less than 2. So, yeah, because 2 is not right, and 2 is not, -2 and 2 aren't right because it's not at or equal to. 4 obviously is not right, so it is 0. And in this case, it is right in the middle. It doesn't have to be right in the middle. Are we pretty comfortable with that? Yes.
Can you show what you did again? I put stuff in, so I don't go on the way.
Oh, so you just plugged them in? Yeah. I just solved it like I did an equation. So I moved my 1 away by subtracting 1 from both sides, both parts. And then I got -4 is less than 2x is less than 4. And then I divided by 2. And then I got -2 is less than x, which is less than 2.
That's 0.
Because it's so it's kind of hard to look at it that way. Let's look at it down here on the separate ones, at least this first one. So if obviously this one is going to end up -1 minus 1, 2x is less than 4, divided by 2. Just did it really quick. So x is less than 2. That's this one on the right. This one, if I subtract 1, I have -4 is less than 2x. Sorry, positive 2x. Divided by 2, -2 is less than x. If you kind of have to flip it, and it becomes x is greater than -2. The way I had my kids kind of do this, so they would remember that they needed to move the sign, is I said, pretend like this is like a train. Pretend like the x is like the locomotive of the train. If you take the train and you make it kind of follow, everything has to follow in relation to what it was before. So it ends up being that sign is flipped. So that's how you know that x has to be greater than -2. So you could look at them separately. X is greater than -2 and it's less than 2. But when you see it as all like one line, you can think of it as x is, as long as these two signs are the same, x is in the middle of the two. Questions? Good? All right. Number 19. Solve for x. Pretty easy, right? Yeah? No? Maybe? 4x minus 1 over 5 equals 2x plus 1. All right. So our goal is to do what? Solve for x. So isolate the variable. First thing we need to do is we need to get rid of this 5. So what is this telling me? What is this showing me? What is, like, if you said this out loud, what is this? Say it, I heard it. It's division. It's 4x minus 1 divided by 5. So we need to get rid of the 5. So the opposite of division is what? Multiplication. So you might remember this. You multiply by the reciprocal. Remember that? Because you want to cancel out the 5. So now we have 4x minus 1 equals, and we'll distribute the 5. So we have 10x plus 5. All right. Now we have x's on both sides and constants on both sides. So we need to move them all the same side. Do you have a preference of x on the right or left, or does it matter? Doesn't matter. Does anyone have a preference?
I just prefer it to be positive.
You prefer it to be positive. So do you want to move the x's to the right then? So she wants to do this. Is that okay with everybody? Because that's going to get rid of the x on there. So if I'm moving the x's to this side, what should I do with the 5? Move it to the other side. And I'm going to, if you're okay with this, I'm going to do both steps in the same step. So I want all of my constants on one side and all of my variables on the other side. So we have -6 equals 6x. Are we with me? All right. And then we just get rid of our 6 by dividing by 6. So we have -6 over 6, which is -1. Would anyone have done it differently? Did anybody just plug them in? You might have, did you plug them in?
No, I have a question.
Yeah.
Where did you get your first 6?
Where did I get this 6?
Yeah.
I moved so it was plus 5, right?
Yeah.
So I subtracted 5.
Yeah.
So now I have -1 minus 5.
Okay, correct. But with the oh, okay, I see. I made a mistake. I did 10 divided by 4 instead of subtracting.
Oh, yep, yeah.
That's where I messed up.
You're welcome. So nobody would plug them in. Would you maybe plug them in if they were all whole numbers and not fractions? Yeah. As soon as you saw -5/3, you're like, ugh, not plugging that in. In this case, it came out to a whole number anyway. Okay, 20. So what's the difference between an equation and an expression? Does anyone know? Expression doesn't have an equal sign. So an expression essentially means you just have to combine like terms, which is essentially what it says in this case. Find an algebraic expression equivalent to this, which just means combine the like terms. Because You can't solve for x because there's no equal sign. All right. We got a lot going on here. What do you guys want to do? What should we do? What'd you say?
I don't know.
Well, I mean, could you just, are we just, pretend they weren't fractions. Pretend they were just numbers. Distribute. So we're going to distribute, even though we're distributing a fraction, which is super, super scary. We'll be okay. And I'll write out the step. So basically, it's becoming this. Minus, I'm going to keep the minus. And then okay, keeping the minus sign because this is a positive. So I'm just multiplying both. So obviously, if you're distributing a whole number, you probably wouldn't write this second step out, but I'm going to write the step out so you can kind of look at it. So now we're just looking at fractions. What are multiple? How do you multiply a fraction?
Multiply the top to the top and the bottom to the
Multiply the numerators, multiply denominators. Or in this case, could we change 3 halves into a decimal? What's 3 halves?
1.5.
1.5. Does this make you happier?
No.
1.5 times 6, x squared. So what's 1.5 times 6? What'd you get? 9. And then the x squared stays there. Minus, what do you do over here?
Cancel.
Can we cancel them? Yeah. The 3's cancel with each other and the 2's cancel. So now we're just left with x. So it's 9x squared minus x. Yeah, you could. She's saying on there you could cancel. Tell her she's here. She can hear me. I don't have to text you.
We're like we've got people watching virtually.
Yeah, people are on the.
Yeah.
That's why the camera's here.
Yeah.
Hi to everyone at home. So she said, can't we just cancel the first one? Yeah, because like the 2 would become 1. This would become 3. Now you have 3 times 3, which is 9. Who's that?
Oh, so it was that Bobby.
Thanks, Rose. So either way, you can do them all of them. Some people just hate fractions so much that they want to change things.
I prefer fractions.
Oh no.
Well, I mean, it's one thing when it's just a regular fraction. It's another if you're talking about like 2/3. It doesn't come out evenly. If you change it to a decimal, now you're dealing with trying to have to like, sort of estimate and all that kind of stuff. So we did a mixture in this case. Any questions about 20? Okay. Let's move on to number 21. All right, this one. When I did this one in the February boot camp, so I learned from all my mistakes with that one. So I did this this is the first time in the February one that I used this particular thing, and I hadn't done the problems ahead of time, so I was doing them with everybody, and I got to this one, I was like, what? There's one in a second that I had Jordan pull up something on the computer, because I'm going to need to remind myself again how to do it. But let's look at this one. A student argues that 4 times the quantity x minus 5 minus 6x minus the quantity 6x plus 1 is equal to negative 2x minus 19. We need to look at basically the way they did it, and it's confusing how they wrote it.
Mm-hmm.
So what they're doing is this is showing the person distributed, and then they got this answer. I would write it vertical, but they're not writing it vertically. So what they did is their first step, they did 4x minus 5, so they did 4x minus 20, minus 6x minus 1. So then they actually didn't even do this part. So then, do you guys see what this is, how it's written? They should have done it vertically, I think. So they basically did this, and they distributed the 4 to the x and the 4 to the negative 5. And now they're here, 4x minus 20 minus 6x plus 1. Are we okay with that still? That's right? So they did this. First time I saw this, I was like, what are we looking at here? So they just went distribute. They have now 4x minus 20 minus, sorry, that's an x, 6x plus 1. So here we are, 4x minus 20, 6x plus 1, right? You guys with me? So step 1 is right. They did the right thing. Step 2, they said they went from this to this. Is that correct? No. What should they have done?
There's a negative in front of the so 6x plus 1, so it shouldn't be plus 1, it should be minus.
So that is the key. 4x plus minus 20 stays the same. If there is a minus and then it's there, you're not distributing a positive. You're not just distributing the negative to the first number. You're distributing a negative 1 to both. So it should be minus 6x minus 1. So this is where their mistake is. You guys see that? So the answer in this one is, where did they make an error? They made their error in step 2. And I agree, this is a very poor way of writing this question because it makes it seem like you're trying to solve this whole entire equation, but you're not. They're just showing their steps. So they're just showing in step 1 that that's how they distributed and, their solution. And then step 2, that's their solution. So they should have had this, and then it would change what the answer is. So we don't need to solve the rest of it, do we? Doesn't matter. They just wanted to know where was the issue. So the key to this problem, making sure when you distribute a negative number, you're distributing the negative to both. So it's minus 6x minus 1. Questions? Anybody at home have a question? We're good?
So wait, is the camera following you?
No, it's just on the screen.
I try to avoid it because I don't really want to be on the film. And we're streaming through YouTube, so Jordan can record it. It's being recorded. So I'm actually gonna, when I email you guys the homework, you're gonna get the feed from this too. So if you want to look back, and it's only good for I think a week.
1 week, yeah.
But if you want to look back and see like live in person what I was doing, if you want to like add me some followers, things like that. I don't know if you can go on yet.
No.
Yes.
You can, but you'd be watching exactly what you're saying here. So, but it'll be on there.
Say that one more time.
Is your April booklet the same?
Similar, yes. Actually, this is better.
Will
No,
it be
really,
the same question?
it's the
I
same
signed
thing.
up for that one too.
Yep, I'm doing the same thing. Some people do come to multiple ones because they want to like hear it once, practice it, come back. So it's perfectly fine if you come. She's asking if the April one is going to be the same as this one. Yes, I do all of my boot camps. I mean, obviously I say slightly different things, but same problems, same materials. The key though, the April one is actually shorter for the math. So I have to somehow talk faster. I don't know. I always run out of time on those. But yeah, it is the same.
Why is it short?
Because we're doing it on one day. We're doing it on Saturday from like 8 to 5. So all of the sessions on one day versus 2 days. So my math is condensed from 5 hours to 3 hours, which is a lot of time to get rid of. Plus,
Bless you.
so I have to somehow condense my things, which I'm sometimes good at and sometimes not. Okay, back to here. I'm talking about expressions again. So remember what I said with an expression. That means you do what? You're just what? Combining terms, everything like that. All right. Ooh, this one. No, this isn't that one. But this is similar. In order to add fractions, what do we have to do? Say again. So because we want to do what? Because what do we need to make sure we have at the bottom? Common denominator. So in this case, we want to make a common denominator. And if you look at the answer choices, 2xy is the common denominator. So I'm going to try to make my denominators the same. And in order to do that, so I have y plus x, just gonna write it on another piece of paper. I have y over x plus 3 over 2y. If I want to make the same denominator, what should I multiply them both by? What do you want me to do? If I'm, can I do this? Because what's 2y over 2y? 1. So I can multiply by whatever I wanted. I can multiply it by 2x to the third, y to the second, and whatever I want. As long as I multiply the top and the bottom by the same number. And then if I want to make 2xy on this side, I can multiply this by x over x. Do you agree that this is going to be 2xy and this is going to be 2xy?
Yeah.
Okay. So now we have on the top, what's on the top then? 2y squared over 2xy plus 3x, right? 3 times x over 2xy. So now do I have a common denominator? So do you see what I did here? I took my rules that I know about adding fractions. That fractions need to have a common denominator in order to be able to add them. And just because I'm dealing with variables doesn't mean I can't follow the same rules. So now if you just thought of like, say 2xy with a 5. Now I've got something fifths plus something fifths for the same thing. So I can just add the numerators. So I can say 2y squared plus 3x over 2xy. And is that one of the answer choices?
Yeah.
Letter D. So the key to this one is just because it has variables in it, use the same rules for fractions. How many of you this is one you might just skip or guess on? And that's okay, because how many can you miss?
11.
This might be one of your 11. I don't want you to stress yourself out. I don't want you to let something like this derail you during this test, because you can miss 11. But just understanding what the concept is important. But if it still is like one of those things where you're like, I'm just not, this one's just going to throw me off every time, skip it and guess. Someone asked me before what my suggestion was. If you were marking and moving on, they said, do you think we should guess something before we move on? My answer is no, because I think if you guess it before moving on, you might be randomly guessing and then you go back to do it again and now you're going to second guess yourself because you're going to forget if you randomly guessed or not. And you're going to be like, but I said it was C. Is it C? You know, my recommendation is you leave it blank and move on. But if you do that, make sure you have enough time at the end to go back if you're running out of time and guess. Because this is not like the SAT where it's counted against you for guessing. Here, I suggest you guess. If you're not sure about something, try to narrow it down and guess it instead of leaving it blank. It's better to have a 25% chance of getting it right versus missing it altogether. Okay. Number 23. A consumer makes a down payment of $250 and plans to pay $60 a month for phone service. If M is the number of months, which of the following equations represents T, the total price paid? Which one is it? Say B. Do you guys agree?
C.
B. Because it's the down payment of $250 plus $60 a month. And this one is classic. Like you'll get one like this and then it might be like, and then how much are they going to pay after 5 months or whatever? So then you would just plug in 5 for M and now you know. So it's just writing an equation out in terms of T. Questions? All right. We're getting closer to that problem, Jordan. Not yet. I think it's on the next page. I need to peek. Oh, I need to speed up, people. I only have an hour. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 questions left. Okay. Don't let me go too slow, but also don't let me go too fast. Okay. Which is true for x in the equation? So what do we need to do? Just solve it, right? I don't like that they call it an equation because it's not an equation. Come on, GKT, it's not an equation, it's an inequality. So we just solve, right? Solve for x. In this case, I'm going to look at the answer choices, and x is on the left, and in inequalities, you want it on the left. So I'm going to move out x's to the left, even if it's going to be negative. So I'm going to add 3x to both sides, and I'll do it separately in this case. So negative 5x plus 3 is negative 2x minus 2 is less than or equal to negative 8. Okay, are we with me? Now I'm going to add my 2 to both sides. Notice I'm not doing nothing to the inequality yet. It's staying exactly the same until this next step. Negative 2x is less than or equal to negative 6. How do I get rid of that negative 2x? Divide by negative 2. And what is the rule about? Flip the sign. If you multiply or divide in that last step by a negative number, you flip your sign. So it becomes x is greater than or equal to 3. And notice they have x is less than or equal to 3 and letter D as an answer choice. If you forget this rule, that if you multiply or divide in that last step by a negative number, you need to flip your sign. Only with inequalities and only if it's a negative, yes. If it was a positive number, you would have left it as less than or equal to. If this had been like a 2x instead of negative 2x, this would have stayed the same.
So how do you know it's inequality then if it's an equation?
I know, they're stupid. Sorry, I shouldn't say that. That's mean. Because there's a less than or equal to sign.
So that's when it's an inequality?
Yes.
Oh, okay.
Equation is an equal sign. Inequality is less than, greater than, all those kind of.
Oh, okay.
Because it's not equal. They're saying that's why it's an inequality. All right. Cool? Ready? Good for number? Yes.
Can you just show the answer for 23 just to see if I?
23? Is
Okay.
that what you got?
Yeah. Okay.
Okay, 25. Which of the following inequalities, so again, an inequality, is a solution to the inequality shown? Keep on going. 10c plus 5. Do we need to see this one for time's sake?
No.
Does anybody want to see this one?
Yes.
Okay, let's do it. Okay, we'll do it. All right, so when you're solving an inequality, you can ignore this sign at the very beginning. Just pretend like it's an equal sign. You're just solving a two-step equation. So you're gonna, but I want to move the variable to the left. So I'm gonna subtract 4c, but in this case, I'm actually also gonna do the minus 5 in the same step, just because I think I'm advanced. But again, if that messes you up, do what I did on number 24 and do it separately. So now we have 10 minus 4, so we have 6c is still less than, so keeping my less than sign. And negative 1 minus 5 is negative 6. And now here I'm dividing by a positive number. So don't memorize it like anytime a negative exists. No, it's only if this number, the first number, is negative. The number with the variable, so that the coefficient. In this case, it's not. So it's going to be c, the inequality sign stays the same, and it becomes negative 1. So c is less than negative 1. So you only flip it if, like on number 24 up here, if the coefficient in front of the variable is negative, then you flip the sign. Otherwise, the sign stays exactly the same.
So how do you know when to add or divide? Like how do you know at the end you divide?
So it's like you're undoing the orders of operations. So you have to undo whatever is there So it's like here, this is like 6 times C is less than -6. So to get rid of the 6, the opposite of multiplication is division. So I'm divide because if I do 6 over 6, that becomes 1, right? Cancels it out. So that's how there's like a 1 in front of that C. And then whatever you do to one side, you got to do to the other. Because it's an equation. You got to keep it, or in this case, it's not an equation, it's inequality, but you got to keep it even. Okay. Do we want to see number 26? Because it's just another one.
Do you just have the answer?
Yes, somewhere.
Oh, it's in the back.
Yeah, it's in the back. What is the answer?
B.
B? So you can check yourself. And I can show it if there's some time. I just want to make sure we have enough time. Because I'm coming up on a problem in a second that I always like mess up on. Always. I shouldn't say that. Now I'm like fixed mindset. And here we are. 27. Okay. Which of the following equations can be used to find the number of gallons of a 50% alcohol solution, X, that should be mixed with a 10 gallons of a 35% alcohol solution in order to get a 40% alcohol solution? So you're doing like this. So notice they put them as decimals. So we're basically doing 0.5, so 50% alcohol solution, X, plus 10 gallons of the 35 solution to equal a 40% solution. And here is where you have to do this. So here's what I did. Because the amount needs to be the same. The number here, I guess I should put in parentheses so you can see kind of the same. So this X is gallons. So we're saying we've got a 50% solution of, what are we talking about here? Alcohol. And a 35% solution of alcohol. And we want to combine them in different ratios. Because obviously if you combined a 50% and a 35 together and they were the exact same amount, it would be halfway between the two. So you would dilute the one. We're doing some chemistry now. But we want to combine them in different amounts. So we're saying X gallons of 50% plus 10 gallons of 35% is going to equal a 40% solution. But then we have to put how many gallons? We don't know. We have the X amount from the 50 and the 10 from the other. So that's value that X plus 10 is there. You with me? So this parenthesis, inside the parentheses, represents how many gallons we're talking about. And the number on the outside represents the percentage of alcohol in that solution. So then if we can just simplify it, we have 0.5x plus, what's 0.35 times 10? 3.5 equals, let's distribute. Do they make us distribute, or is the answer there?
Is it C?
Oh, sorry, it is C. They don't even want us to distribute. See, they've got this. This is the answer. They don't need us to go any further than that. Thank you. Because I would just keep going. We could solve for X, right? If you wanted to. You could solve, you could actually solve this to figure out how many gallons of 50% would need to be added. But they don't even want that. They want to know which equation can be used to find it. And that's the equation. We good? All right. Jordan, I did it. This is the one that last time I felt so badly for the people because they just met me. You were there. Yep, I felt so badly because they had just met me and I was like, don't lose faith in me. I'm like, they're going to lose confidence. They're going to be like, she doesn't know what she's talking about. We're going to fail this test because that girl doesn't know what she's talking about. I do. This question was a little weird. So I think I got it this time. Yes, got it. And I can even send you the website where I found it. Well, Jordan found it for me. Okay, what is our rule about functions? No x's are repeated. And if it's a graph, how do we know no x's are repeated? Vertical line test. So if a vertical line goes through every point and it doesn't hit it in more than one place, then it's a function. Is letter A a function? No, because if I put a vertical line through here, it hits it in 2 places. So A is not. Well, we can see C. What about C? No, because it goes through that circle in 2 different places. So C is not. What about D? No, you can even say this because this is probably going to keep going and this probably, but you can already see. So our answer is B. That parabola passes the vertical line test, so it is a function. Super simple. If you remember the rule, this is a question you're going to get in 30 seconds. And you're going to be confident about it. All right. Number 29. Which one of the following best describes why the following is a function? So again, what do we know about functions? No x is repeated. Every x value only has one y value. So for every person, they're talking about a person, they only have one height. Okay, so which of the following best describes why the following is a function? Each student in a class, for students in a class, assign their height. Each student has a student number. Well, that has nothing to do with height. Students will only have one value for their height. Is that correct? The height of each student can be easily measured. Well, true, but that doesn't tell us why it's a function. The chance of 2 students having the same height is small. But does it matter? Like, I don't know who in here might be my height, but say we have the same height. If we have the same height, it's still a function because I only have one height and she only has one height. So multiple people in the room can have the same height. That's the y. But the x is each individual person only has one y. So I'm 5'7". I'm not 5'7" and 5'8" and 5'6". I'm only one. Is anybody else 5'7"? Is anybody else 5'6"? Okay, so she's 5'6", I'm 5'6", but we both have our own height. It's okay if we're both the same height. So it's okay if that y is repeated. So if we wrote it out in a chart, you wrote your name or whatever, or your letter and your number. It's okay if 2 of us have the same number, but it's not okay if you have more than one height, which is impossible. So that is why this represents a function. There's only one y value for every x value. Like your age is also a function. If someone was to say, for every person in the class, give them their age or write their age down. Your age is your function because you only have one age. You are not more than one age. So just think about anything that there's only one of for you, then represents why it's a function. Couldn't be like anything there's 2, that wouldn't be. All right, so like look at number 30. It represents graphically that same idea. So the input, so every input, that's the x, can only have one output. And let's just make sure they say which one is a function. Yes, they do. Not what is not. So in other words, the x's cannot be repeated. So which one is a function? Why B?
It only has one line for each, when all the other ones have, at least one of them has 2.
So notice going out of the x, right here, like this one. And if you wrote them out, it would be like saying 3 and 1, 6 and 1, 6 and 2. So there you see, your x's are being repeated. Over here, it would be 2 and 2, but then also 2 and 5. So the x's are repeated. So that's what these little double things mean. So B, but it's okay that the 1 and the 5 both went to 2. It's okay, because that's the y value being repeated. If you have 2, so you can remember what they mean, and instead of being like mixing yourself up, write it out like I just did. It's basically, I'm just writing out an XY table. 2 and 2, 2 and 5. 4 and 5, 6 and 5, 6 and 8. So you're noticing 6 is repeated also. Pretty easy?
Yeah, so it's not a function if the x repeats.
Yes. The x x's are repeated, it's not a function. Alrighty. We're doing great on time. Now I've like had too much time. It's okay. Same thing, more functions. Which of the following input-output tables represents a function? So again, we're looking for what repeating? No x is repeating. So is A a function?
No,
No, because these are repeated, these are repeated. B?
no,
No, those are repeated. See?
no.
No. I hope B is, because none of those are repeated. And it's okay that those are repeated. So it's just the input, the x's. The input is the x, the y. Do you guys remember learning that as like a kid? They had like the little machine, I always called it the machine. Like the equation or the number goes into the machine and the machine might be 2x plus 7. So a 3 goes in and it does something in there and it comes out as an output. The inputs are the x's, outputs are the y's. Always drew a little machine. All right, 32. The equation of line A is given as 2y minus x equals 6. Select the equation that could represent line B. Well, if we look at them, what do we know about B and A? Oh, someone had a question about something. Let me go back.
What is the difference? What's the difference between the inputs question? How do you determine that?
Oh, determine the difference between them? I don't know if I understand what she's asking. She asked, what's the difference between the inputs in 30 and 31? The input is just the number on the left. So this is still a y, or the x. This is still the x. This is still the y.
Did it swap in the following problem?
No? They're still input, output.
Still the same.
Yeah, they're the same. Inputs are the left side for the x. Outputs are the y. Not quite sure. See if that answers your question while we do 32. Okay, so what do we want to assume about these two things? Anything? These two lines? They do intersect. Do we want to assume that they are perpendicular? I wish that they had done that. I think you can pretty much assume that looks like a perpendicular line, right? Right? Yeah. What do we know about perpendicular lines and their slopes?
She said so the output is the y.
I'll get back to you in just a second. What do we know about perpendicular lines? Opposite reciprocals. So how are we going to find the slope of this line first? It has to be in what format? Y equals mx plus b. So I need to move everything away. So I'm going to go like this, add x to both sides. So now I have 2y is equal to x plus 6. And then I'm going to divide by my 2. Now, everything needs to be divided by 2. Do you guys see that? Doesn't necessarily matter in this one because all we're worrying about is the m, so the number in front of the x. But every part of the equation on the right should be divided. So now we have y equals, I'm going to write it as a fraction, 1/2 x plus 3. So my m is 1/2. And what's the opposite reciprocal of m? -2. So the opposite, one's positive, one's negative, and you flip them. Yes, ma'am.
Did you get the half?
So this is like there's like a 1 in front of the x.
Oh, okay, you're supposed to pretend there's a one, because I used to.
Plus 2. Yeah. It's because since you have to know what the coefficient, so the number with the x is, you have to write it as like a 1/2 versus x over 2. Yeah. So the opposite reciprocal is -2. So let's just double check. All of them are in slope intercept because the y is by itself. So which one has a -2? Letter C.
Well, it has +7.
It's okay. Because remember the last number is just the y-intercept,
Okay.
which line A is the positive one. So this is supposedly a 3 because the y-intercept is a 3. And then this should be a 7. Yeah. Cool. Wow.
What's the little symbol that you wrote next to the end?
This?
That's like the opposite.
Oh,
Yeah,
this means perpendicular.
Oh, okay.
That's perpendicular. Oh, sorry. That's perpendicular. Yeah. You're like, oh, I think I've seen that before. Questions?
I'm just so confused how you recommend it out of
Oh, because remember if a line is perpendicular, then it is the opposite reciprocal.
Okay, so we would
Flip it.
over one and then that's where you get your
Yep.
negative.
Yep, because it'd be like -2/1, which is -2. Yep. She had a question. What was her question again?
Her question was, so if the output is the y, why does it matter that they repeat?
You don't want the x's to repeat, but it's okay for y's to repeat.
Okay,
I think she can hear me.
okay.
Right? Can you hear me? It's okay if the y's repeat. So like I just gave the example in the class where if two of us have the same height, our y is repeating, but ourselves, I only have one
She
height.
said for question 30.
Question 30.
If the output is the y, why does it matter that they repeat?
Because you don't want each x can only have one individual output. So like letter A, this 6 has 2 outputs. That means the x is being repeated if you were to write them twice. So each x can only go to one y. But it's okay if 2 x's go to the same y.
She said I understand now.
Okay, good. Any other questions? Yes.
So, is this actually mine now?
Yeah.
Okay, can I right now take mine next to questions I want to know?
Okay, cool. So anybody have like a question that might be relative to everyone? Okay, so we're gonna have a little longer of a break. That's nice. We're coming back at 1:30, but we're going to EDU 317. So EDU 317. Is anyone not familiar with the education building?
Oh.
Yep, education building 317. And I'm happy to stick around for the next 30 minutes to, if you have any questions for me. Otherwise, I will see you after lunch, 317. And if you're not from here and you want to know where to eat or anything like that, let me know and I'll help you kind of navigate that too. Cool.
Saying that they're order right now.
And if you're not coming back this afternoon, if you would please do the evaluation and leave it in the folder back there, that would be very helpful. And could someone turn the light on back there for us whenever you walk that direction, please?